Hello everyone. So I wanted to give you one more example of some of the weirdness that can happen with limits, multivariable limits, limits being taken on the xy plane. So right here, we've got the limit as x and y go to the origin, so go to 0, 0, of x cubed times y squared divided by x to the fourth plus y to the eighth. Okay, so if we just look at this right now, because on the top we have x cubed times y squared, if we look at this on either the x-axis or the y-axis, we can see that the top is always going to be 0 in either of those axes because one of the coordinates is going to be 0. And so no matter what, on those two axes, the limit's going to be 0, 0. So next, I want to look at it, what happens to this if we look at straight lines going towards the origins. And so if we take the vector function at comma bt, well, so in this means that if you look at this, if I do b times at, that's equal to a times bt, because we can rearrange the multiplication. And so this means that bx is equal to ay, and so we can think about this as being ba times x is equal to y, so long as a is not 0. And so by choosing different values of b and a, we actually can get any slope that we want here. And so by just leaving a and b as variables, this in some sense is trying all the possible lines through the origin at once. Okay, and so if I plug this parameterization into the limit, so at comma bt going to 0, 0. So my x cubes turn into at's, my y's turn into bt, so at to the fourth plus bt to the eighth. So really now we're looking at this limit as t goes to 0. How can we simplify this? So on the top we have a cubed b squared t to the fifth over a to the fourth t to the fourth plus b to the eighth t to the eighth. So if you look on the bottom, we can factor out a t to the fourth from here. So I can get rid of that, and that exponent's going to turn into 4. And so then we have a t to the fifth on top and a t to the fourth on the bottom. Well, that's going to cancel off to just a t on top. And so the a cubed times b squared over a to the fourth plus b to the eighth times t to the fourth, if a and b is, this is never going to be, this is always going to be less than infinity as t goes to 0. There's no problems with this. And so this is all going to some constant as t goes to 0. Right. However, on the top, we have this being multiplied by t, and so this is going to be a constant times t, but the t is going to 0, so that limit is always going to be 0. Okay, so for any line going in towards the origin, on every single one of these lines, this limit is going to 0. Okay. So does that mean that the limit has to be 0? And the answer is no. So let's go back and rewrite the limit. Okay, so now I'm going to look at it along a parabolic path, but parabolic in sort of the sideways parabolic. And so this is going to be, so this is the line x is equal to y squared. And so that actually can be parameterized by t squared comma t. And you can double check if you plug in t squared for x, you get t squared is equal to t squared. And so that works. Okay, so what happens if we plug this parameterization in? T squared comma t going to 0 comma 0. So I'd have t squared cubed times t squared over, this would be t squared to the 4th plus t to the 8th. And so now this limit is just in terms of t going to 0. So on the top I have t to the 6th times t to the 8th over t to the 8th plus t to the 8th. This should be t to the 6th times t squared. Excuse me. And I was saying t to the 8th because it equals t to the 8th. And so out of this we get t to the 8th over 2t to the 8th. And so then that limit is 1/2, right? Which in particular is not equal to 0. So even though on every single straight line to the origin, on each of these paths, the limit equals 0. Instead, if we take this parabolic path, like this, all of a sudden we can get this limit going to a different value, equaling 1/2. And so this really is some of the really extreme weirdness that can happen on the xy plane. And so I hope that this example helps some.